Well, welcome everybody to Tech Talk Tuesday. I'm Dan Conger, and I'm Baseline's training manager, and Idral Bowen. Idral, you're a regional manager, and is it the Southeast? Is that your territory?
That's what it's called today. Yes.
Okay, that's what it's called today. Okay, great. As I mentioned, Chris and Andy can't be with us today, so I already planned on being out in the field. So that's what we're doing today. And this is Tech Talk episode number 33 of season 2. You can find all the other episodes as well as some training videos that I've done on YouTube, and our YouTube channel is Baseline Web Training. That's all one word together. And I'll have this recording up this afternoon or sometime tomorrow. I'll have this recording on there, and I'll add some show notes as well. So today I'm on site, and we wanted to talk about 3-point grounding and actually do a 3-point grounding test. And I thought it was important to kind of frame this and kind of talk about why. So last week, Idral was on, and he was on a lightning-prone site. And I think we were starting to drive some of the significance of lightning protection and grounding protection. So today, I've got the equipment to do testing on those ground points. So a couple of things that so we wanted to drive that. The other reason we want to do this was actually, we did this very similar to this June of last year in season 1, and I did it with a slightly different piece of equipment. So it was really popular. So we wanted to kind of feed that, the popularity, that significance. And then the other one is I got some new gear. So I wanted to share that. So let me show you some of the equipment that I have, and then I'll talk about the equipment that we're going to be using today. So I'm going to come around here, and probably a good time to spotlight me since we're going to show my gear. So what we did last year in June is we did a 3-point grounding testing with this. This is an Aemc 4630. This is a 3-point and a 4-point grounding tester. And we use this device. And this device is really robust. It's really strong. It's also kind of heavy. It's a little bit more expensive. But this one, we have a grounding connection, the red lead or the Z lead, which is the furthest one out, that's stationary, and then the blue one, which moves in various increments. And we did we call it a 62% test. So we did a measurement at 72%, 62%, and 52%. So we did those and came up with a reading. So this is what we used last time. But I've got a new piece of gear, and I have the Aemc 6422. This is definitely more compact. It only does the 3-point grounding testing. It does not do a 4-point ground test, which is definitely more advanced. It's lighter, it's smaller, it's easier to use, and it's actually a little bit cheaper. So currently, as of right now, we have a baseline part number for the 4630. And you can get that either with, if you're a distributor, with Baseline Bucks or purchase it directly. We currently don't have this as a part number. My suspicion is I think we may change over to this one, but if you don't even have to get it from Baseline, you can get it from electrical supply place. So that's 2 pieces of equipment. We're going to be using this tester today. The other thing that I have is what Idral had last week was a clamp-on meter. And Idral, how often do you use your clamp-on meter out in the field?
Actually, I use it fairly regularly, just to check grounds, just as a matter of course. When we walk up to a site, if we're doing troubleshooting, we'll clamp on and get a reading to see whether they've applied for the 10-year warranty or not. It's a good idea to make sure you're grounded.
Absolutely correct. So what's interesting is this device is certainly even more compact than this. And well, you might think, well, I want to use this out in the field. And Idral, would you describe where you use this versus where we'd use one of these 2 devices?
Well, the one in your hand, yeah, the clamp meter is only used at the controller where you're taking the chassis ground. You can't use it on the field grounds. You've got to use the other 2 devices. Right.
Absolutely right. So to make this work, for this to actually have an accurate test, you need to use the ground that's built into the electrical grid system. So, if you were to think about your house has a ground rod, or any other device has a ground, either a floating ground or a true ground, and we're going to be using part of that to make this system work. This device doesn't need that. So now you could use this device on the controller ground or the chassis ground. Or this is super simple, right? That one's just a clamp on and boom, it immediately tells you if it has it. So excellent. The other thing I have out here on my table is I have my cheat sheet. This is a document that we have on the Baseline website, measuring ground resistance with the 62% method. Okay. Actually, the URL's up here. All I did was print this and laminate it. The first time I had to do a ground test in the field when I started with Baseline, I had no idea how to do it. I read this, 10 minutes, boom. I actually understood everything I needed to know. So I laminate this and just keep this in my kit. The other thing I've done is I've applied my cheat sheet information, which we're going to talk about in just a second here. This is good information that I've added on. So this is, I don't need this for today, but it's nice to have. Okay, so let's talk about what we're going to be doing. So we're going to be doing what we call the 62% method. So we're going to measure the ground resistance between the ground point, which is the ground rod along the 2-wire path, and then the earth that's around it. And as we talked about last week, we want low resistance. We really want the smallest number possible. Idral, what were those? There's 2 different numbers on the for our target on ground resistance.
So what we're after, yeah. So on the 2-wire path, what I typically am shooting for is 25 ohms or less. Okay. And on the controller, I'm always after 10 ohms or less. And those are our 2 target numbers.
Okay. Excellent. So the 25 ohms or less is our hard spec. The 10 ohms or less is our preferred number. So, and what's interesting is I will probably always shoot for 10 because I know that, and I'm sure most people that have dealt with 2-wire systems and lightning prone areas have kind of recognized that when you have lower resistance at that ground point, you have less damage to your system. So if I had a ground point that had 100 ohms or 200 ohms, to say, I've met the spec, I've got an 8-foot rod in the ground, I've got the wire connected, I've got the surge arrestor. Yeah, but it's hard for the energy, that surge of energy that's coming down the 2-wire, it's hard to get that off the wire path and back to the earth where it belongs, right? And that's what we want to do. We want to make it super easy to off-ramp that energy and not damage equipment. Because if it's difficult, it's just going to stay on the wire, which is a super easy path, and just destroy device after device. So low resistance. That's
also part of the reason why in the Southeast, particularly with the higher incidence of lightning strikes, we want you to shorten the distance between those ground points because you're protecting devices. You're not protecting the wire. And so the closer I am together, the most I can afford, the more devices I'm apt to protect and keep from having to replace in a lightning situation.
That's a really good point because as we talked about last week, our hard spec is every 600 feet along the 2-wire path with a few extra restrictions or extensions, but generally 600 feet along the 2-wire path. And so what we're saying is if by spec you're grounded every 600 feet and in between those 600 feet that something is destroyed by a lightning surge, which is quite possible if it jumps on there, we're going to warranty that out if you're eligible for the warranty. To Idral's point, if you shorten that distance to every 300 feet, well, then you're going to have fewer devices that will be damaged. So the more lightning strikes you have, the less components you want to ever have to replace, warranty or not. And because that's downtime for your system. Okay, so let's talk about the process. So the process is we're going to connect to the ground rod. So what I've got, so I've got the green lead here, which is connected to my meter on the green. So let's come back to my meter again. There we go. So on my meter, green jumper, green lead plugged in. Okay, that one's good. And I'm going to connect this now to my ground rod. So I'm going to go off camera and connect it. Okay, I've got my ground rod. The other thing I've got is this red lead here. So this red lead is attached to a spool of wire, and I've got a clip, and I've got a ground probe. And this is just going to clip onto this ground probe, and that's connected to the meter. And I'm going to poke this into the soil. Now we're going to go out 10 times the length of my grounding rod. So Idral, ready? You got your calculator ready?
Yep.
Okay. So if I've got an 8-foot rod, I want to go out 10 times the length of that. What's the math on that one?
That's an easy one. 80.
Good. 80 feet. So we're going to go out 80 feet. So I've got this clipped on, and I need to grab my tape measure. So I'm going to get my tape measure and run this out. And run that out my 80 feet. And then come back and get my probe with the red lead attached to it and go out to 80 feet. And what probe is that?
This is like on your car where it says objects are closer than they appear in the rearview mirror.
Right. Okay, so that one is at 80 foot, and I'm just going to leave that red lead there. And here's the other one, the way I've idiot-proofed it to a degree, is I have, let's see it. I've actually put just a little label on here that says stationary. This reminds me, this red one doesn't move. It's just going to be there the entire test. The other thing I've done is I've put the 0 end of the tape measure at the ground rod and run it out. So I'm just going to run that tape measure and leave it. So I'm going to go the full 100%, 80 feet, and just leave the tape measure there. Then we're going to come back in to 72% of that reading. So 72% of 80 feet is what, Idral? This is some math. 58 feet. Okay. So take my other ground probe, connect on there, and we're going to go, I'm sorry, that number again was what?
58, 5'8", sir.
5'8". Yeah, I got short term. Okay, so we're going to go 58 feet. And then attempt to get it in the compacted soil here. And what's good is this has got some clay in it. So let's talk about soil type a little bit. Clay soil can be compacted. It's hard to get it in. Sandy soil will penetrate and go in really easy. Idral, being from the Southeast, you're more likely to have sandy soil. It's, well, actually not all of it, but in certainly in Florida is more prone to sandy soil. Tell us about grounding resistance between clay soil and sandy soil. What's your experience on that?
Well, you've actually lived it with this, where you put a probe in the sandy soil, and it can be in the hundreds. Now, you sometimes are going to have to amend your soil to get a good ground, even on the 2-wire path, because it's not the same. It's not as resistive.
Right, and that's due to it's all about particle size. So fine granule soil, clay and silt, lots of soil particles to touch that ground rod or that probe for that matter. Coarse, gravelly, or sandy soils, there's less contact with it because there's bigger particles that touch that. The other thing that happened is some sandy soils have a lot of silica in them. Silica is what glass is. Glass is a wonderful insulator. So generally, sandy and gravelly soils have a harder time getting that low resistance, but it's going to be really easy to drive the rod. So there's that catch-22. But then you put sandy soils with silica in lightning-prone areas. Ooh, we got a real challenge there, right? That can be really tricky to get that low resistance. Okay. The other question, since we're talking about that, is a lot of people are probably thinking grounding rod, but there's also grounding plates. In your experience, Idral, which do you see more of, grounding rods or grounding plates?
It's more rods. We do have some specifiers who are doing rods and plates. Mm-hmm. And then we'll see in areas where they don't have room to get the 8 feet away from the 2-wire path, a pretty common use of the 4-foot grounding plates, like in a median strip or something, to still get outside the sphere of influence and still get the connectivity and the ground that we're looking for.
Yeah, that's a good point. So, I think that's because rods are cheaper and they're really easy to put in, and plates are just more expensive. Yeah. So if people, I mean, I've been a contractor, right? So if you can put it in for cheaper and it's going to do the same thing, fantastic. Okay, so, sorry.
I was just going to say, just keep in mind though, if you're in an area that is having trouble getting good lower grounds, the ground plates have a lot more copper surface area touching the ground. And there's a percentage number. It's quite astounding how much more copper surface area there is on a ground plate, whether it's a 4-foot or the 8-footer, compared to a ground rod. So
Good point.
sometimes when you're in those bad spots and you can't get a ground, you might really consider the ground plates. It might be the only option.
Yeah. Okay, so I've got a couple of things. So we've got my green going to the ground point, the blue going to the mobile point, which was at 58 feet. And then the red, which is solid and it's going to stay stationary, and that's at the full 80 feet. Okay, so we've got our three leads hooked up. And then this meter, we're just going to turn it on. So I'm going to hold down the power button and turn it on. Okay, and we got a little bit of glare there, but that's about as best as we can get. So I powered it on, and it's just an LCD screen. And then I'm just going to hit test. And I'm going to hit test. And there's our current resistance. Okay, so a couple of things that's really nice about this one is I hit test, it holds that number. Where this other device, you need to record it. You need to record it. This one is going to be staying on the screen until I clear it to do the next test. So first reading Idral is 77.7 ohms.
Yep, I got it.
Beautiful. Okay, so now I'm going to go back out in the field. And we're going to do our second reading, which is going to be 62%. And what's that number going to be?
48 feet.
48 feet. Okay, 48. Get that in the ground.
The water comes flying up, you might just pack up real quick and run away.
When I do this on site for training courses, I'm always nervous about driving a temporary ground rod that I'm going to hit someone's main line or electrical utility. Well, those kind of scary thoughts. Okay, so we got the next reading, and let's test this one and see what we come up with. Okay, there we go. Whoa. Okay, let's rerun that. Okay, 76.99 ohms. 76.99. So here's a thought. That resistance got just a little bit lower as we came closer. That kind of makes sense. The shorter the distance, the number's going to get a little smaller. Okay. Now, the other thing we're looking for is a variance of no more than 5% between our three readings. Because if we see dramatic readings, there's a problem either with our probe placement or our ground placement, or there's some other problems. There's a technical problem. So if we have more than 5%, if I had a 50% drop off between those readings, we'd need to throw those out and redo the test. So only looking for 5% variance. Okay, so that was our second reading. We need one more, and that's going to be, what's our third distance at 52%?
42 feet.
42 feet.
Yep, and we've got some questions coming in, which we'll need to answer here shortly. But
beautiful. Okay, well, let's run our last test.
Yep.
And let's see what we come up with. 76.47. Okay, so we've got three numbers to work with. So now what we're going to do is those apps, without doing the math on them, that sure look like we're within 5% of each other. So we'll take these numbers. What do those three numbers average out to, Idral?
They average out to 77.05.
77.05 ohms between the ground rod over here and the soil that surrounds it. Now, I could go in any direction. I don't have to go along the wire path. I could go that way, whatever makes sense. So 70 some odd ohms doesn't meet 25 ohms, doesn't meet 10 ohms. Fails, absolutely. Okay. So I've got a couple questions that we can talk about on how to get lower resistance, but what you want to bring up some of the questions that have come in?
Okay, so one of the questions, and I think we may have talked about it with Tom Glazner asked, how do you account for changes in the soil moisture? And yeah, there are a couple things, right? So, I want to show you something. I'm going to flip around my camera here and show you what's on the other end of this park.
Okay, that is the field that's over here. The resistance in that field is going to be crazy, crazy high, assuming that I could get a ground rod in there. So moisture content does have an impact on the resistance between there. So if you have high resistance, here's a, well, I'm going to actually back up. New installation, drive the ground rod early. Okay, let it settle in. Because what happens is you end up with these air pockets around there, and that adds resistance. The other thing is drive it early and put it in an irrigated area. Start irrigating your soil, right? So if you started from bare dirt, it's bone dry, perhaps hasn't been irrigated for months, you're gonna have very, very high resistance. If I had to put a ground rod over in that field over there, that's not the end of the world. I'm gonna put one spray head or one rotor and just always irrigate that area to help keep the resistance there. The other thing that makes the difference is irrigating this area here. Now, irrigation actually has more about how you're going to drive the probe in there, right? Because if it's dry and I have to hammer it, it's kind of hard on the equipment, but it also creates those air pockets around there. Air is insulating. So moisture does have an influence on it. The other thing about this is technically you should be doing this test periodically, probably on an annual basis. It's really only required one time for warranty, but it's good to do a regular test on it, and that would really kind of drive your moisture checks.
Right. Very good. Another one that is a Florida question. How does a shallow groundwater elevation, like 4 foot, affect grounding results? From my experience, it can help. It can be of use. You know, you're getting into that water table. One particular project that I saw went in, they were trying to get their rods down into the water table by pounding rods on top of each other, and it wasn't helping. And it also caused an ancillary problem that it was now getting into the controller got into the sphere of influence. So groundwater is good. Going 40 feet to get to groundwater is bad.
Sure. Okay. So you said sphere of influence. So I'd like to address that and I'm trying to watch our time too. So yeah. Sphere of influence is relative to the length of the ground point or the ground rod. So an 8 foot rod has 8 foot either direction, so 16 foot diameter, and then another 8 foot below it. So imagine a sphere, and that's the area that it would radiate its energy back out. That has what we call the sphere of influence. So an 8 foot rod needs to be at least 8 foot away from the wire path. Okay, so if I move that rod 8 foot 1 inches off the wire path, that's great, and it won't transfer the energy back to the wire path. But to Idral's point, what happens if I have low resistance and I just extend it and turn it into a 16 foot rod? Now I have a 16 foot sphere of influence, and it is impacted by the wire path, and that can be an issue. Earlier, we also talked about plates. Now, plates have a much smaller sphere of influence. So a 36 or 48 inch plate is only that diagonal distance. So if you were to take your plate and measure from corner to corner, that's essentially the sphere of influence, and that's the length we're going to treat it as. So a 36 inch plate is less than 37 inches. It could be much closer to the rod. And to Idral's point, you get much better contact with the soil because remember we said air, big soil particles, they don't give good contact with the soil.
Let's go to this another question on here. What grounding compounds do you recommend? So while you're talking plates, let's talk about the power set. And I'd be honest, we've seen people, particularly in Florida, use an additional wetting type agent. There are different brand names, different distributors sell different products that actually attract moisture into that power set product, and then also keeps the plates moist or more moist with the help of pulling whatever moisture is available into it.
Excellent. Yeah, I don't have a whole lot of experience with that, and we don't have a recommended brand. I think there's only 1 or 2 set materials on the market, so I don't think you have a whole lot of choice. And that's an interesting concept of adding a moisture holding component. Is that kind of like the gel things? Is it similar to that, perhaps?
It's similar. They're not generally gels because they generally expand and explode out of the ground. But they're I apologize, I don't have a better name for it. But they're more of like a turfist type product. Some of those products that soak up water.
Sure. Okay. All right. I can picture that. I could see that. I could see that helping as well. Yeah. Things that would hold moisture. Absolutely. Because again, that field that's off camera, that's going to be very, very high resistance, and it's for sure driving that rod. One last thing on rods and plates. Clay soil, nice deep soil without rocks, a rod is going to be, obviously is going to be the easiest, cheapest thing, right? You could just drive that sucker straight in. But where I live in San Diego County, we have most of our soils are really rocky. So if we have these cobbles mixed in with clay, which is a horrible digging, but you go down 2 foot, you're going to hit a rock this size, or you might get 6 foot. And then what happens is you're tempted to cut it. That's going to be a problem. So plates are much more common in my county, because what's nice about that is we don't run a whole lot of chain trenchers in this county. We do a whole lot of mini excavators. So for our main lines, we'll just dig a trench with a 12-inch or 18-inch bucket. And then when you're ready to set the plate, you just use the backhoe and open that up, put your set material, the plate, more set material, and you don't even have to do any hand digging.
Let me add something real quick. I got this from John Bannock, and I've seen this before. Power set is meant to be used in sandy soils, and power fill are meant to be used in clay type soils. They have a different makeup to help with the type of soil. So like you said, there are a couple different products. So you need to get the one that suits your location best. So,
and I'm going to do the lawyer part of this, like check their specs. That was probably the best thing to do, is to read their set specs on that one. So, okay. So question for you. We had 77 and some odd ohms here. How can we get lower resistance on this? What do you think we could do? We got to cut. We don't necessarily know why all we know is we failed. We don't know why.
Can I answer?
Please do. Yeah.
So, maybe additional rods, additional plates, water it in.
So multiple ground points. So if I did multiple ground points and connect them all together, that would lower the resistance. Okay, cool. Make sure we got enough moisture content. That's good too. Yeah. Those are probably the two biggest things. And then make sure that I have the right length rod, right? Because if I was using an 8-foot rod and I ran into the rock, contractor fly by night Joe here, if I just cut it off, it might look like I have an 8-foot rod. In fact, it's a 4-foot rod. We're gonna have really low resistance. So here, let's do a test here. Let's come back and look at my meter, and let's spotlight this again. And so we said this was, turn it back on. It says a power saving function, which is kind of nice. Turn it back on. We got just under a couple minutes. So, okay, so we said, it's changed a little bit. Interesting. 75.77 is what we got now. I've got a second ground point off camera that I'm going to clip in. So I've got a jumper here, and we're going to cut that in and see how that changes things. So let's see how that changes things. That's an anomalous test. Let's run that again. Should be going down. Oh, interesting. Come on. No, it's not going down. Oh, that is quite strange. Okay, well, my something's changed. Okay, well, whoops. So much for that. It worked earlier. Okay, well, I have another ground point. So I have some problem with my temporary ground points here. So the idea is that what I wanted to illustrate was I went from 77 ohms to 35 ohms by adding in another ground point. Didn't happen today. So, but that can do it, right? Then I would test all of my ground points as a grid or as a system. And that's not uncommon. Like electrical substations or people that use this equipment quite frequently, they will test an entire grid system. So. Okay, I think we got like another minute or two. Any last questions that popped in, Idral?
Nothing new at this point.
Okay, great. So here's, I think I kind of want to close this and frame this with this equipment. So even the cheaper, smaller meter, it's not particularly cheap, and it's chances maybe you want to own it, maybe you don't. Your distributor probably has access to it or can get access to it, and honestly, your distributor is the person that can run this test. So if you're a distributor, I think this is a great resource for you. That smaller meter, and it's I always forget the model number, 6422 or 6424. Either of those from Aemc, they're probably even easier to use than the other one. Come with the same reels of wire, the same probes. So if you don't have one, it's a great tool to have. But for contractors and end users, what I think I'd like you to take away is that grounding is important and low resistance is important. And there's real equipment, real test equipment that you can use to test it, not just meeting the spec of an 8-foot rod or a 3-foot plate. It's having low resistance to those ground points. Okay, I think it looks like we're perfect. We're right at the half hour. So we will be back next week. Next week, we're going to be talking about flow station, and we'll see if Chris and Andy are back from their Manhattan vacation. Idral, hey, thanks so much for joining me. I appreciate your time today.
Very good, sir. Hope it helped.
Okay, we'll see you all next week. Take care, everybody.
Take care, everybody.